So today we're going to start surface area, and we're going to talk specifically about rectangular prisms. Surface area, like its name suggests, is the area of the surface. This only works for three-dimensional figures because if it was flat, if it was two-dimensional, we would just call it area. We wouldn't call it surface area. Surface area is what you can see. If you imagine wrapping this with some wrapping paper or painting just the outside, that would be considered the surface area. It doesn't worry about how much it can hold. That's volume that we studied last week. This is just what it takes to cover the outside. Now, most of us in today's society would be like, well, I'll just get a little bit of extra in case I need it, or I'll just get a bigger package. Well, let's say, for example, that you were going to cover this with really expensive fabric. You don't want to pay any more than you have to cover this box. And it's not just for boxes. That's just the shape that we're dealing with today. Let's say that you were going to paint this with gold paint. That's really expensive. I don't want to pay any more than I have to. So I want to know how much it's going to cost me to cover just the outside of this. All right. Now, this is one that I've made. You can see that it's a rectangular prism. It has length, it has width, and it has height. So if you can, I don't know if you can kind of see, there's writing on the inside. There's actually grids on the inside. We could count and then multiply and figure it out. There's another thing. If you've ever heard of a net, this is the exact same. I made a duplicate, so I had two of these. This is the exact same box flattened out. Okay, so if I was to fold this back up and tape it so it actually stays, it is the exact same box as I showed you to begin with. Okay, but what's nice about having it open like this is what's called a net that you can fold up and make the shape. I can see all the pieces of this. Now, there's a formula I'm going to show you in a minute, but you can always break surface area apart. This is composed of 6 rectangles, and I've color-coded them because on this box, you know that the top and the bottom are the exact same rectangle. Well, in this case, it would be, this is twisted a little bit, it would be the pink ones. Okay, so that's this rectangle and the rectangle that matches it on the bottom. Then there are 2 sides. Like if I held my fingers like this, like corn on the cob holder skewer things, those 2, those are the white ones. Again, they're the exact same shape. They're congruent. And then we have the front and the back. And on the colored one, it's the green ones. Okay, so I wouldn't have to find all 6 rectangles. I could find just 3 and then double it. I could find a pink, I could find a white, and I could find a green, and then I know that there's 2 of each of those, so I would just double it. Now, there is a formula that might make it even easier. Let's go to the book. I'm going to be on page 764. All right, zoom in a little bit more. This is not a difficult thing. What makes it challenging is that there's lots of steps. So you have to be kind of organized. You have to take a breath and fight your way through this. It's not hard. You've done area. That's all we're really doing. But there's a couple steps involved now. So you could do piece by piece by piece like we did here. Add them all up. That would be fine. You could find 3 of them, add those up, and then double it because there's 2 of each of those. Or if you didn't want to go through the headache of having to do individual rectangles, there's a formula. And this only works, this particular formula only works for rectangular prisms, square prisms too, because they're a type of rectangle. It will not work for triangles. It will not work for circles. It will not work for pyramids, only for boxes. Okay, so 2LH, 2 times length times height, plus 2LW, 2 times length times width, plus 2 times H times W, 2 times height times width. These are all of the combinations of this. Okay, so if I think about my pink rectangle here, I'm going to flip this over just so that I can kind of form it back to what you saw. Okay, if I think about my pink rectangles, those might be length times height. If I was to build it up like this, okay, that would be the length and that would be the height. And there are 2 of them. If I think about this white one on the bottom where my finger is, this one that says side, it would be length times width. And there are 2 of them. And then if I think about these green ones, well, that would be width times height as it comes out of the paper to you, right? And there are 2 of them. So that's all the different combinations. It does take a little bit to remember the LW, LH WH, all the different combinations of them. But after you do a couple of these, you get into a groove. Now, if the box is presented to you like this, the picture like this, it's real easy because you see the L, you see the W, you see the H. If it's presented to you like this, you got to do a little bit more thinking, maybe visualize it being put together. So let's go down and do an example. I'm going all the way to the bottom to the dotted A. Okay, here we've been given a flattened out net, and this is actually a square, so it complicates things because two of them are the same. What I like to do, I write out the formula, 2LW plus 2LH plus 2WH. Now, this is backwards from what it shows up here. Does it make a difference? No, because commutative property of addition says that I'm allowed to switch them around. I still have an LW and I still have an LH. I just did this one instead of this one first. No big deal. Okay? The other thing I like to do is set up which number goes for which letter. And again, if I look at the box like this, and I call this side length, and I call this side width, and I call this side height, but you look at the box like that and call this length and this width and this height, is it really going to make a difference? No, it's the same box. You'll be okay. All right, so if I'm looking at it like this, and this is one of the reasons that I held it this way, okay, if I'm looking at it like this, and I think about folding up these pieces, I'll even turn it this way. I think about folding up these pieces. This is going to be 10, which means this is going to be 10, right? Opposite sides of the rectangle. So all of these lines going across are going to be 10. It tells me that this is 10. My picture doesn't match, but you'll get the idea, right? So this would be 10. So if I was to fold this up, I would consider, I got all kinds of stuff here with this video. I would consider this to be height, which we just said was 10. So I'm going to say my height is 10. And I would consider this to be width. And we said that that was also 10, right? This line here. So then the only other number I have to worry about is length, right? If I fold this up, I've got my width, I've got my height. Now I just need length. Well, the one I see here going this way is 15. Now that I've established which one's going to be length, which one's going to be width, and which one's going to be height, all I got to do is substitute. No big deal. All right, so let's see. 2 times 15 times 10, right? Because L was 15 and W was 10, plus, you could even do them in parentheses if you wanted to be able to see the 3 pieces, do something like this. That way you know that goes with that one. All right, 2 times L is 15, H is 10. This is going to repeat a lot. Plus 2 times 10 times 10, because W is 10 and H was 10. And then you just go through and calculate. 10 times 15 is 150, times 2 is 300. Same thing here, another 300 because it's the same numbers. 10 times 10 is 100, plus 2, or times 2 is 200. 300, 600, 800. Now, let's talk about units. When we studied area, we always talked about square units. Well, this is a type of area. Even though now we're talking about 3-dimensional shapes, it's still area. So my units here will be square inches because my sides were measured in inches. All right? I'd like to go through one more of these with you. If we shift over, let's look at got it B. All right? My formula does not change. Surface area equals 2LW plus 2LH. Oops. LH plus 2WH. I'm going to take a second and go over here and say length, width, and height and list my numbers because it makes it so much easier. There's no confusion. So whichever one you think is length, I think I'm going to go for 4. Whichever one you think is width, I think I'm going to go for 3, front to back. And then whichever one you think is height. There's only 3 numbers given in this problem, so each should only appear once. You should have no duplicates. If you flip these around and you said width was 4 and length was 3, fine. It's fine. All right, now we're going to go do some substituting. So L is 4 and W is 3. 2 times 4 times 3. LH. L was 4, H was 2. And WH, W was 3 and H was 2. All I'm doing is replacing these letters with the numbers that I decided over here. And then I just calculate. If you've got a calculator that can handle it, put it all in at once. If you're using a phone calculator, something that it has to be done piece by piece, do this, do this, do this, and then add them up. So 2 times, I'm going to do 12. 4 times 3 is 12, times 2 is 24. 4 times 2 is 8, times 2 is 16. 3 times 2 is 6, times 2 is 12. And then we'll add them all up. I know this is 36, 46, and 6 more is going to be 52. My units were meters, and since I'm talking about area, I'm going to use the label squared. You can do it piece by piece. You could do the front and the back and the side and the side and the top and the bottom. And there are some cases where you're going to have to do it piece by piece. But for the boxes, the rectangular and square boxes, you've got a formula that will work very efficiently.